In chemistry, it is not just enough to qualitatively talk about solutions like we've been doing right now, so components and solutions. We also have to have a way to measure them quantitatively. And this is where we use solution concentrations, whether we talk about ionic or molecular solids that are dissolved, it doesn't matter, but we use concentrations to deal with solutions. Now here's two different terms that we're going to learn. A solution that contains a small amount of solute, so not much solute, is said to be dilute. But one that contains a large amount of solute will be concentrated. Now, these aren't absolute terms. We can have many dilute solutions or many concentrated solutions, but know that if I'm talking about dilute solutions, I have very, very little solute dissolved into my solvent, and the opposite is true for concentrated solutions. Now we can use several different ways to describe the amount of solutions, the concentrations of them, and they depend, so which one I use depends on particular conditions and how I need to use this information for the solution, right? So we're going to use several different types of or different ways to write concentration for solutions. We first start by percent by mass. This is just a percentage where I'm taking the mass of my solute over the mass of my solution times 100. That is what percent by mass means. Mass of solute divided by mass of solution times 100. Note that this is a unitless number because I have grams, the mass of solute in grams, divided by another mass in grams times 100. The grams cancel. Also note that the mass of solution is given as the mass of your solute plus the mass of your solvent. These are very important to keep in mind when you do problems with these. A lot of students will forget that the solution is made up of the solute plus solvent. Have this handy to use with problems. You don't need to memorize it necessarily, but have this somewhere written out in a nice organized note cards or whatever, organized way so that you can refer to it when you do problems. Here's a sample problem. Determine the percent by mass of each of the following. If I have 29.5 grams of MgCl2 dissolved in 100 grams of water, 37 grams, 3.72, dissolved in 500 grams, 278 milligrams dissolved in 475 milligrams. For this last one, make sure that you convert the milligrams to grams. But let me show you how to do, obviously we're going to use this particular formula, so the mass of my solute, which is going to be one of these, the mass of these salts, over the mass of the solution, which is going to be, right, the mass of my solute. This is my solvent, so solute plus solvent. If I'm just going to do the first one for you, here's my mass of solute. That's what I'm kind of determining what I know first. My mass of solute is given as 29.5 grams. The mass of solution, however, is not given to me, but I can calculate it because I know the mass of my solute and I know the mass of my solvent. So if I add those two together, I will get the mass of the solution, and that is 129.5 grams. Now, I can use this particular formula because I know everything that I need. I have the mass of the solute and the mass of the solution. So I divide 29.5 grams by 129.5 grams. My grams will cancel, multiply by 100 to give me 22.8% by mass magnesium chloride. I will give you some time to work on B and C. Here's a slightly different sample problem. Determine the mass of the solute that is present in each of the following solutions. In this type of problem, you are given the mass of the solution, and you're also given the mass percent of the solution. What you need to do is assume 11.8 grams of your solute per 100 grams of solution, but you have 250 grams. So here's I've worked number one for you. Okay, so if an 11.8% solution by mass tells me that I have 11.8 grams of sodium nitrate for every 100 grams of solution. But what if I have 250 grams of solution? Then I can set up this proportion. So 250 grams of solution multiplied by 11.8 grams of NaNO3 over 100 grams of solution. This will cancel out, leaving me with 29.5 grams of NaO3. Now go ahead and work on BNC. Make sure that you convert this milligrams to grams before you continue.